Welcome to the walkthrough of the specification, skeletons, and unit tests for assignment 3B. The purpose of the second part of assignment 3 is to deepen your experience using Java's functional programming features together with Java sequential streams and their integration with the Java fork join framework. In particular, you'll update your assignment 3A implementation to use the Java fork join framework and Java sequential streams to obtain, store, and transform images in parallel. As with the earlier assignments, there's a GUI that runs as an Android app, and please use this GUI along with the JUnit test discussed below to help test and debug your solutions. There's a bunch of other videos you can watch to understand this assignment. We've covered all these material in class, so you can also, of course, go to my YouTube playlist there and watch what we had from this semester. Naturally, before you start working on assignment 3B, you need to finish off your implementation of assignment 3A, taking into account my review comments. Please come to office hours if you have any questions whatsoever about my comments on assignment 3A or any of the other parts of the assignment that depend on proper implementation for these tests. The assignment structure and functionality is identical to what you've seen before. You have to use Android Studio. There's an app written with both Kotlin and Java that demonstrates many Android capabilities. You, however, only have to be familiar with several directories. The utils and crawlers directory that's part of the image crawler package, which contains the skeletons you need to fill in, as we talk about momentarily. And there are also several test directories that you'll need to do in order to be able to make sure your code is working. Please make sure your code passes the tests. I've been noticing on recent assignments, people are submitting their code without passing the tests, and that is very frustrating because it means a lot more work to review things. If you take a look at the to-do tasks in the skeletons, you'll see that you have to fill in a new fork join crawler 2.java file, which contains the code that you'll have to complete to obtain, store, and transform images. This class, as we saw before, will use the fork join framework to do an image crawl starting from a root URI, and it'll either do that from your local file system or go across the network. The main difference between this solution and for assignment 3A is you have to use Java lambda expressions, method references, and sequential streams for all the code in fork join crawler 2.java. So before, you could implement it using for each loops and other Java 7 constructs, but now you actually have to use sequential streams and, of course, lambda expressions and method references and so on. You'll also have to implement the synchronized array.java file, and naturally, you'll also have your original unsynchronized array.java file, which is used by synchronized.java, and this will give you a chance to learn a little bit about how to wrap code that's not thread safe with a thread safe wrapper or a facade, or maybe a better way to put it is a decorator. It's like the decorator pattern. The skeleton code is available in my GitHub account in the normal place, in this case for assignment 3B. You should have no problem downloading and integrating that into your repository on GitLab. There's a bunch of unit tests that you need to run as always, so make sure you run those, make sure those tests work before you push your initial selection and solution. This assignment is designed to give you more experience programming directly to the Java fork join framework APIs in conjunction with Java sequential streams. There's a bunch of moving parts in this assignment. We're not leveraging the streams and parallel streams, in particular the parallel streams code to do parallelism here. We're relying on sequential streams and the fork join framework. So it's a little bit trickier. Make sure that you start the assignment soon and come to class, office hours, to ask questions, and also feel free to post questions on the discussion forums. Everything that we give you is extensive and very interesting, but you don't have to understand all of it in order to be able to complete your solution. Now that we've walked through the specification for assignment 3B, let's take a quick look at the skeletons. A lot of this will be familiar to you. You have to implement the array collector as you did before, so just go ahead and copy that in. Should be no changes. You should make sure that you integrate your array splitterator. Please double check to ensure your splitterator is working properly. There were some people who had problems with that in the previous assignment for assignment 2 and lost some points for that, so make sure it works properly. Naturally, you have to have your unsynchronized array implementation. And then one of the new things you're going to have to do for this one is fill in the synchronized array. And as you can see, this is essentially a wrapper or a decorator around the unsynchronized array. So this is going to ensure that access to the array with the synchronized array will be properly synchronized, so it'll be thread safe. There's no opportunities for race conditions. And that just gives you a little chance to learn about synchronized blocks, basically. So that's essentially what you have to do for utils. That's fairly straightforward. You have to do a little bit of work with synchronized array. Over here in the crawlers folder, you can see that this is cumulative, so make sure you integrate your working solution for sequential streams crawler. Make sure you integrate your previous solutions for parallel streams crawler 1 and parallel streams crawler 2. Make sure you integrate your solution for fork join crawler 1. And then the new implementation that you have to provide is fork join crawler 2. So let's take a quick look at the skeletons that you have to fill in. Don't worry about the make fork join array for this one. We don't have to worry about that for this assignment. Where we have to start doing things, first implement the various factory methods to make the perform transform task, make the process image task, and make the URL crawler task. These should be really straightforward implementations. Don't do anything the least bit tricky here. It should just be a straightforward making a new instance of the appropriate class defined below and passing in the right parameters. Here's URL crawler task. This looks similar to before. The main difference now is that everybody is going to need to implement the solution using sequential streams and the fork join framework. So down here, you will write a sequential stream that will appropriately do the work to create the forks array with the appropriate fork join task objects corresponding to each of the image or page element types that are on the page. And so you have to fill that logic in. And then once you've got the stream, then you have to go ahead and use another sequential stream, a different sequential stream, to join and sum all the fork tasks and return a count of the number of images on the page. Make sure you go back and watch the frequently made mistakes discussion from assignment 3A to ensure you do this correctly. In particular, you need to make sure you use the result coming back from the join call to do this properly. And in all these streams, make sure that you try wherever possible to do proper method reference usage and make sure you format it properly and make sure you comment each of the aggregate operations appropriately. Here's process image task. As with before, you have to write the compute method for that. Once again, what we're going to do here is we're going to implement an appropriate Java sequential stream that will create a forks array, and it'll have the appropriate fork join task objects that correspond to what you need to implement to enact or invoke the perform transform task logic. So that has to go in here. And then you're going to go ahead and do the logic here to update transformed images with the appropriate results. And then that final return statement will return the appropriate count of transformed images. Again, go back and watch the 3A frequently made mistakes video to see the common problems people were doing in assignment 3A. Please do not repeat those problems again in assignment 3B now that you're using Java sequential streams, and make sure you fix them in assignment 3A as well. And then the final class to implement is the compute method for perform transform task. This is pretty straightforward. I think most people got this right, but just make sure you copy and paste your code in properly. Go back and watch the video again. Make sure you're not making any of the mistakes that I describe in the video. So that's basically what you have to do for this. It's not that much more tricky than assignment 3A. You just have to make sure you understand how to use a sequential stream properly to put all the code to do the forking and the joining in the correct and efficient manner. So now that we've walked through the specification and the skeletons for assignment 3B, let's go ahead and show what happens when you run the tests. So as usual, you go to the test folder and run the edu Vanderbilt.image crawler tests. And as you can see, these tests are intended to be cumulative, so they'll run all the tests from assignment 1, all the tests for the different variants of assignment 2, the tests for assignment 3A, and so on. And if all goes well, you can see that we'll test the fork join crawler 1 implementation, we'll test the fork join crawler 2 implementation, we'll test the parallel streams crawler 1 and 2 implementations, the sequential streams crawler implementation, the array collector, for grads and undergrads, the synchronized array tests, and those should also be done for undergrads as well as grads, as well as all the various unsynchronized array iterator, split iterator, and just general unsynchronized array tests. So quite a number of tests here. If all goes well, everything should work properly, and you should end up with no red marks or no yellow marks. Everything should say test passed, and the check marks should all be green, as you can see here. So as I said before, please make sure that you run the tests. If you have problems running the tests, any of the tests, come to office hours. Don't wait until the final submission, at which point you will lose lots of points.